Is the universe infinite? It takes some mental gymnastics to wrap your head around how big the universe is. And we're not even sure of its actual size. Think of it this way. In a single second, light travels around 300,000 kilometers. The distance that light traveling at this speed travels in a year is called a light year. The observable universe is 93 billion light years across. What lies beyond that, we don't know. We can't observe it in any way possible. And we're not really sure. So we suspect that there's still a lot of universe beyond that. Though we're not sure how much. Although astronomers have frantically looked for an answer, we also don't know if the universe is infinite or not. And to make matters even more complicated, infinite might also mean more than one thing. So let's see what we know so far, what the plausible possibilities are, and what we can guess off of that. The observable universe. The fact that we know the observable universe to be 93 billion light years across is astonishing. That's a great story in itself. But how do we know it? Well, the story starts out with an Australian mathematician and physician called Christopher. In the 19th century, Christopher tried to explain an unusual phenomenon about electromagnetic waves. If an observer moves towards or away from a source of a wave, the length of that wave decreases or increases respectively. This is now called the Christopher effect and was confirmed for essentially all types of waves. For astronomers, this is extremely important. You can look for all sorts of anomalies in the wavelengths you're seeing. If you're seeing increased wavelengths, the object is moving away from you. And if the wavelengths are getting smaller, it's moving towards you. In the 1920s, Edward discovered something unusual. Sure, some things are moving toward each other and others are moving away. But in a general sense, everything seems to be moving away from everything else. Simply put, the universe appears to be expanding. This was truly a groundbreaking moment. A shift from the universe, which was once thought to be fixed and stable. Not only that, but this universal expansion also appears to be accelerating. We still don't know exactly why or how this happens, but subsequently, measurements have confirmed or refined this idea. Studying redshifts is fundamental for studying cosmic distances, especially for things which lie far away. But this is where things start to get a bit tricky. If you're looking at something that says 1 light year away, you see it the way it was 1 year ago. But in that year, the universe has expanded. So the distance you and that object is now greater than 1 year. Astronomers' observations have found the age of the universe to be around 13.7 billion years old. And one of the furthest objects we've ever discovered is a galaxy. This galaxy is 13.4 billion years old, which is incredibly old. However, although it took some light years from it, 13.4 billion, to reach us, the galaxy lies way further than 13.4 billion light years away. In fact, Astronomers believe it took to be a whopping 32 billion light years from Earth. So it's misleading to think that the age of the universe in years also represents its size in light years. But we can go even further than that. We have no idea where we are in relationship to the universe in general. But there's no reason to believe that we can occupy a special position. At any rate, the observable universe is estimated to be about 93 billion light years. But what lies outside our observable universe? We don't know. There are different studies attempting to calculate the real size of the universe. For instance, one statistical estimate carried out by Oxford researchers found that the universe might be 251 times larger than the observable universe, which would put it at 23,343 light years across. Even so, that's on the conservative side. If the universe were to be this big, then even if it's not technically infinite, it could still be practically infinite. Nothing from our location could reach its edge or vice versa. But it gets even weirder. The observable universe is 93 billion light years across. This would mean that the points that are furthest away are receding at a speed of about 20 million kilometers. That's almost 10 times larger than the speed of light. But the theory of special relativity tells us nothing can move faster than the speed of light. So what gives? Well, technically, the universe isn't moving. It's not like something is moving at 2 million kilometers. Space itself is expanding at that rate. General relativity does a better job of dealing with this type of contradiction. But even general relativity is, in a sense, a local law, which local being limited to our universe. We have no idea what's going on outside the universe, if such an outside exists, or even makes sense. Furthermore, notice that the expansion rate isn't a speed, it's a speed per distance. So while cosmetic objects are getting further away from one another, they aren't moving away from one another. But if you were to try to reach these from far away places, you would have to travel faster than the speed of light, which is impossible. You can even calculate that objects further than 40,740 are moving away at a rate higher than the speed of light and could therefore never reach one another. Galaxies closer than that are still emitting light that can reach us, of course. This all relies on the assumption that the universe will continue to expand, which may or may not be true. The universe could stop expanding or start collapsing onto itself, for all we know, or it could expand faster or faster forever. So even if the universe is not theoretically infinite, from a practical point, it quite likely is. But that still doesn't really answer the question, does it?